My name's Greg Darcy. I'm part of the team that works in the Social and Cultural Informatics platform here at the University of Melbourne. For today's short tutorial, we're looking at a general introduction to APIs, specifically for humanities and social science researchers. So researchers from all corners of academia, public, private sectors, are very interested in looking at how they can extract and use textual data from various social media and online platforms. And what do they do with this data? Well, this data can be used to answer all sorts of questions, from social attitudes, trends and fashions, consumer behaviour, political deliberations, interpersonal relationships, and a vast array of other social phenomena data. Well, the web's providing endless opportunities for areas of research in machine learning, natural language processing, as we can see from this image, social network analysis, and data visualization. So, as data gathering from online resources has become more and more interesting for academic researchers, in practical terms, the typical workflow for a researcher would involve these steps. 1, acquiring the data. 2, cleaning the data. 3, then carrying out their analysis. And finally, visualizing the data. So for the purpose of this tutorial, we're really focused on the first aspect, gathering the data. Now, there's many ways to get data off the internet. The simplest, obviously, being simply downloading a file from the internet. In this instance, we're looking at Excel or CSV, but could be Word documents, PDFs, are easily available and able to be downloaded. But in this sense, we're specifically looking at the conceptual basics of data collection through using APIs, or otherwise known as Application Programming Interface. So the aims of this tutorial, hopefully by the end you'll understand a little bit more about what APIs are and how they work. You'll understand the use and limitations of APIs for data collection, and we'll learn some basic methods to query APIs in order to obtain data. So broadly, textual analysis is a term for various research methods used to describe, interpret, and understand texts. For researchers interested in internet-based methods, terms such as web scraping and data mining are often used interchangeably to describe techniques to collect and organise textual data for analysis. It's probably worth making a distinction about these terms. So web scraping tends to refer to the process of automatically extracting textual data straight from web pages or other digital files. Now APIs work a little bit differently. APIs provide data in a digital format that computers can understand and use. Quite often you'll hear this referred to as machine-readable data. So what is an API here, you ask? So typically, if we think about some software that may be sitting on the internet, we're looking at a single computer that pretty much has a single job to do. It does that job well. But it does it that well that we might want to connect it to other services or computers to get them to work together. So as we can see from this illustration, we pretty much have a black box that is unable to integrate or connect to anything else. Now, APIs are often described as the glue that sticks computer systems together. So instead of building large monolithic programs, we can create quite complex applications by hooking together smaller, specialized programs. So as we see here, we're still using our black box metaphor, but very much looking at how these things connect and interchange information between themselves, each one doing a very specific function. So black boxes are all well and good, but how do these things actually work? Well, we all would be engaging and using APIs probably on a daily basis without even realizing. So services that we're quite used to having on our mobile phones, mapping services, checking calendars, that kind of thing, would tend to use APIs in order to be able to exchange and write data from your device to the main server that hosts your account. In this instance, this is a graphic showing one of the functions specifically of the Spotify app. Platforms tend to have a number of APIs, each one specifically for a particular purpose. So whether it's to share or pull in your playlists, to be able to use the social aspects of these platforms, each one of these functions is pretty much hooked up to an API that carries that out. But as well as from commercial terms, APIs open up the possibility for us to build and create new tools and new services. So what we see here is the front page of a tool created by Tim Sherratt, the real face of White Australia, that basically used a machine learning algorithm to be able to extract photos from records from the National Archives of Australia and basically assemble those into a new interface to be able to look, investigate and access those records in ways that weren't previously possible. So APIs, how do they work? Basically, APIs use the established protocols of the World Wide Web. So these have been around for a while. So these protocols, HTTP, is basically the protocol that we might use to, as we are on our computers, browsing the web, looking at websites. So we can see here that we've got someone clicking away. They put in a request to a browser to say, I'm searching for something. That request then gets sent to the particular web server or website, and then the results are sent back and are displayed in this instance in that browser. So the request and response is that once you make a query, you get back some results. Now APIs leverage this technology as well, but instead of sending back a nicely formatted web page, they deliver back data in a form that computers can understand and work with. And how do they do that? Well, the instructions are very much defined in the URL that gets sent to the web server. So as we can see here from this example, we'll see the first part of this URL is the actual API address, or sometimes referred to as an endpoint. The final part of the URL that we see there in red actually sets the criteria for the resource we want to get returned to us. So while humans can easily interpret information on a web page, computers need a bit more help. It needs to be very explicit in terms of the resource number or a particular query that we're looking for. And typically this is what comes back. So this is a response. This is a standard format. Usually the APIs send back data in a standard format such as XML or JSON, and basically what we get back is something then that a computer can understand or a programming application can understand and work with. So again, probably already mentioned this a few times, but in summary, websites are for humans. They listen for URLs and deliver nicely formatted web pages that humans can read. Web APIs specifically for machines. They also listen for URLs, but they deliver nicely structured, machine readable data. So, in the context of research, what are some of the issues we need to think about if we're when using APIs? So again, it's probably worth coming back to this distinction between web scraping and APIs. So when using textual data that we extract through either method, there are a few important things to consider. In both cases, the data provider, the website, or the person that are the platform owner that makes the API available tends to set restrictions on how their content can be accessed and used. Now, as a method, word scraping tends to be a bit more flexible in that it can be used pretty much on any web page. The flip side to that is that the tools to scrape data from pages can be a bit more difficult to use and may violate a platform's terms of service. So websites tend to have a crawling policy that states which parts of the site can be crawled. Generally, and as you can see from this URL here, many sites have a text file that sits in their root directory that has instructions that stipulates which parts of their site can be crawled for data, which sites can't, and also which crawlers can and cannot use or crawl their website. So terms of service, most social media companies like Facebook, Twitter and LinkedIn require users to agree to a terms of service agreement as you register an account. So generally, this grants them permission to use the content you post on their website and indemnifies them against any libelous or defamatory materials that you might post on their platform. Now, within the context of APIs, there's a different set of requirements, and those are that APIs define the structure that you can extract, but also the policies that they set in terms of what you can and can't do with that data. Importantly, not all APIs work the same way, and the use of data, as I mentioned, is strictly regulated by the API provider. So, as an example, in April 2015, Facebook closed its public search API. Since then, privacy concerns and the monetization of data access has meant public and open APIs have often disappeared, or there's been greater restrictions imposed on using those services. Standard, in terms of limitations, APIs can put limitations on how many requests you might make per minute, hour or day. The standard Twitter API is a good example of this, in that it only lets you collect tweets going past in the last 10 days and doesn't provide you with any mechanism to work with historical tweets. Now, a key issue, I think, from a research perspective, is that it's worth remembering, obviously, ethical issues are a major consideration in any form of online research. So by following or employing terms of service compliant methods, you may be respecting the business prerogatives of the company that created the platform you're studying, but not necessarily the dignity and privacy of the platform users. For example, Twitter allows scholars to harvest enormous data sets, but it's important for us to consider the human effects of working with and representing people's statements out of context, particularly where the public nature of Twitter that makes the data available also makes individual tweets searchable and traceable. Now we'll have a closer look at how APIs are used for data collection. So to collect data through an API is only possible if you have authorization to do so. So there's a few steps you need to go through before you can start collecting data. To begin with, you need to develop or open a developer account with the platform or provider that you intend to use. Once you've done that, you need to register the apps that you're planning to create. Once you've created an app, then you're issued with an access token and an access key, and these are the bits of information that you will then pass to the API that indicates that you're authorized to use the API and collect data. So let's have a bit of a closer look maybe at the Twitter API. So as I mentioned, there's the URL there. If you're interested in collecting tweets from Twitter, you go to the developer.twitter.com and register your interest for a developer account. Once you've created your app, you're then issued with a number of keys and tokens. Now, in this instance, we're going to be using R. R is quite a popular and free programming language that's used very widely for data analytics and has quite a number of libraries that can be used for text mining, data cleaning and manipulation, as well as visualization. So in this case, we'll be using an R package called rtweet, and you can see the URL there. Now, to begin with, this first block of code is basically setting up and telling our R script what are the packages we want to use to carry this out. So we can see that there's 3 packages I've installed there, and then once those are installed on my computer, I then basically have to call the library for each one to be able to access the functions and objects within that package. The next step for our code is that we have to create an authorization for a token that we will then send to the Twitter API. Now you can see here that this has got the information that we've just covered. So we can see here that if we're going to create a new token, we need to insert the name of the app that we created, and then we can see that there's 4 other fields: consumer key, consumer secret, access token, access secret. Now these are generated by the platform, and you literally just cut and paste those into your script and save those to file. Now when it comes to our query, so we're all set up, ready to go. We have our access token ready to roll. Basically then we need to look at the query that we're going to send to the Twitter API in terms of the information we're looking for. So this is a pretty straightforward query. We can see here the function search tweets. The first parameter there is the query term, which I put in #cats. So I imagine we'll get quite a bit back. N equals 18,000, so that's the maximum number of tweets that I'm looking for. I'm not interested in retweets or replies, and in this instance I'm interested in tweets that are in English. So once we execute that, we then look at the tweets that come back, and what we see here is that I've saved those tweets to a variable called tweets. Sample n is I want to see the first 5, and I'm telling the script to show me or select the following fields: the date where the tweet was created at, the screen name of the user, the text that was included in that tweet, the number of favorites or likes that tweet might have received, and how many times it was retweeted. So we can see there for the first 5 tweets in that data that was returned, we can see the results. The final block of code that I've got there is simply straightforward function, write as CSV. So basically then I'm taking all those tweets that I've saved and I'm telling my R script to write that to a CSV file and save it to my computer. Now the following example was quite straightforward. We only had one query term. We can of course build up more complex queries. So to have a closer look at this, we might look at the Trove API, which is generally well used by researchers and archivists in research. So the Trove API is based around multiple zones, and these zones, you can almost think of different type of content collections. So as we can see there, the zones include book, picture, article, music, map, collection, newspaper, gazette, list, or maybe all. So a simple search would look a little bit like this, very similar to the one that we just used for Twitter. We can see here at the end of the URL that where we have result question mark, what we need to do is insert the key that we have, our Trove key. After that, we're stipulating the particular zone we might want to look at, be it newspapers, maps, collections, and then again query Q equals the particular search term that we're interested in. Now we can drill down even further in Trove by using faucets, which are categories that can help restrict our areas to very specific queries. So we can see here that the faucets include another set of criteria, which are place, format, decade, year, month, language, title, and category. So what would that look like in a URL? Well, as we see there, what we've got in this example is we have the same style or structure of URL. We've got the key, with the zone is book, Q is whatever search terms we're looking at. But in this instance, we're using, we have the parameter for faucet, and we're saying we're interested in the format faucet, and we're particularly looking for theses. So once we enter our key, our particular search term, we save that into the URL. Once we paste that into our browser, what we will get is some well-structured data that's querying Trove and returning any results based on those sets of criteria. So if you're interested in having a go with Trove, I would suggest this is some steps you could follow. Obviously, as we've kind of established with APIs, you need to start off by getting a Trove key. Then try constructing a simple two-term search query on the newspaper collection, and have a look at how you can limit the search to a specific number of records. One way too is once you've had the results returned in a JSON format, it's quite easy to paste that URL straight into that JSON to CSV converter, and basically that other website allows you to download the file straight to your computer. If you're interested in delving a little bit deeper into Trove, I would suggest having a look at these links. The Trove API workshop goes through in far greater detail than I've covered in terms of some of the parameters and query strings you can put together to query Trove, and obviously the API technical guide goes through in detail as well. So where to next? Now, if this is of interest, but you feel like you don't have an IT or programming background, there are different tools available, and really these are coming, there's new ones every day, where you can use APIs from different platforms to sort of stitch together or create little workflows to perform functions. So I would suggest going and having a look at this site. It's a little bit hard to see. I think the URL's displayed over the bottom of the graphic there. It's ifft.com, and basically these are almost like little building blocks that query APIs that you can stitch together. So for instance, you can see there, post an Instagram photo, but automatically send it to the Facebook API to post there as well. Another way to actually kind of get a little bit deeper into it is that a number of the platforms have a API console. So what we're looking at here is the Guardian's console. Trove has a console, and what you can do here is play around with some of those parameters, play around with creating those URL queries until you start to get closer to the results you're looking for. So quite an easy way to test and iterate as you go. Finally, if you really want to get into the nuts and bolts, I would suggest looking at Tim Sherritt's Glam Workbench. Tim's done an amazing job pulling together a number of Jupyter notebooks that query not just Trove, but the National Museum of Australia and a number of other repositories and government websites to pull down data that then is basically there for analysis in one of his Jupyter notebooks. Tools for web crawling, Scrapey and Arvest. Scrapey being a collection of Python scripts, Arvest R scripts, obviously very straightforward. Really, these are just text files. Once you cut and paste into a text file and save, if you execute them, obviously you need to have Python or R installed on your machine. You'll get results. If that doesn't take your fancy, these other software that you can download and then use to basically point towards websites and start extracting text that way. So, as I said at the outset, this has been a very gentle introduction. I hope it's sort of given you a bit more detail in terms of what APIs are and how they work, and enough information to continue on and explore them a bit further. So, thanks for listening.